Presentation has been developed as part of the Navy SBIR Transition Program, STP, to acquaint Navy personnel with Alphacore's work funded by the Navy under the N68335-23-C-0314 SBIR topic to develop a gigahertz optical underwater detection receiver and to seek opportunities to further mature and then insert this technology to the benefit of Navy programs. The title is Gigahertz Optical Underwater Detection Receiver. Topic is N212-126 for the Office of Naval Research, and the program manager is Andrew Levy. This is a detailed script that aligns with the titles and bullet points of each slide in Alphacore's Tech Talk PowerPoint presentation for this topic. The script provides cohesive narrative that aligns with each slide, effectively conveying. Welcome to today's presentation on Alphacore's innovative gigahertz optical underwater detection receiver. This technology is designed to address critical challenges faced by the Navy in underwater detection and imaging. Our focus in this project has been to deliver high sensitivity, wide bandwidth optical receiver capabilities capable of capturing detailed data in cluttered underwater environments. As you'll see throughout this presentation, our solution not only meets but exceeds the Navy's requirements, enabling faster and more accurate detection and imaging. Let's dive into the details of this project, beginning with Alphacore's technical capabilities, the challenges faced by the Navy, and how our solution is tailored to overcome them. Alphacore brings together a world-class engineering and leadership team with extensive expertise in delivering innovative data converters, RF, analog, and mixed signal products, as well as complete imaging systems. These solutions are tailored for critical systems and are rooted in a history of success spanning startups and multinational companies. Alphacore has built a strong legacy of successful commercialization across its analog, mixed signal, RFIP, and imaging solutions product lines. These advancements are primarily fueled by research funding through Small Business Innovative Research, SBIR, and Small Business Technology Transfer, STTR programs. Notably, the portion of revenue derived from commercial business is steadily increasing. From 2015 to 2023, Alphacore achieved a remarkable compound annual growth rate of over 60%, which demonstrates consistent and robust financial performance by the company. Our expert leadership includes Dr. Esko Mikola, Alphacore's founder and principal investigator, who has over 20 years of experience in high-performance mixed signal design. We have diverse revenue streams where Alphacore's revenue comes from R&D grants, IP licenses, product sales, and design services. We have a comprehensive system design expertise in-house, where Alphacore excels in developing complete camera systems, including optics, board design, integrating FPGA interfaces, firmware, and software. This expertise makes the company a perfect fit for programs involving avalanche photodiodes, or APDs. And finally, primarily, our prime location, we're situated in Arizona's Silicon Desert, and we are positioned at the heart of a thriving technological ecosystem. And as far as innovations for Navy programs, Alphacore is actively contributing to cutting-edge Navy projects, including the development of a 1 gigasample per second ADC for next-generation air-to-war LiDAR systems requiring ultra-high dynamic range. This work aligns with the Navy's CMOS receiver needs for LiDAR applications. Other notable innovations include our high-performance ADCs, silicon-evaluated designs such as a 10-bit 2.5 gigasamples per second, ADC consuming only 6 milliwatts of power, exemplify our expertise in efficiency and performance. Optimized pulse digitization. These ADCs are specifically engineered to function as pulse waveform digitizers, handling input signals characterized by randomly occurring double exponential pulses with rapid rise times and slower fall times, perfect for applications requiring precision and adaptability. So this blend of technical excellence, innovative capabilities, and a proven track record position Alphacore as a leader in advanced electronics and imaging solutions for critical and emerging applications. Overall objective is the development of wide bandwidth multi-element optical receiver. The specific goal is to design and develop a multi-element optical receiver capable of gigahertz level bandwidth to extract reflectivity and range features of objects in water. This advanced receiver combines high sensitivity at visible wavelengths with the dynamic range necessary to detect and differentiate signals in cluttered environments. The image on the right illustrates Naval Air Warfare Center Aircraft Division's, or NOCAD's, novel hybrid LiDAR-radar system that will ideally benefit U.S. Navy's airborne mine countermeasure ship missions programs. Accurate time-resolved detection is essential for underwater imaging, particularly for distinguishing desired object returns from environmental clutter. To effectively identify underwater threats, the system must achieve spatial and temporal resolution of at least 5 centimeters. Alphacore's solution addresses these critical needs for 1. Enhanced resolution with a sub-5 centimeter resolution in both space and time domains. 2. High sensitivity with optimized performance at visible wavelengths, especially in the blue-green spectrum. And 3. Dynamic range with capability to function in environments with significant clutter and signal interference. This technology is targeted to support the General Warfighting Requirements, or GWR, enhancing the Navy's capability to identify and respond to underwater threats with precision. The optical receiver from Alphacore has design targets with the following criteria. 1, it's a multi-element design that incorporates over 10,000 optical receiver elements and facilitates simultaneous sampling across all elements to ensure efficiency and accuracy. And 2, wide bandwidth, which achieves a minimum of 1 gigahertz bandwidth to process high-frequency signals efficiently and effectively, and supports gigahertz bandwidth signal processing without compromising any resolution. 3, blue-green sensitivity, which is critical, and it optimizes optical sensitivity for wavelengths in the blue-green spectrum, which are crucial for underwater imaging due to superior light penetration in water. And 4, signal processing capability, which integrates advanced methods to handle gigahertz bandwidth signals in real time and ensures capabilities with high-speed sampling technologies for reliable performance. This technology is aligned with the General Warfighting Requirements for underwater threat detection and response. It falls under the broader categories of sensors and weapons technologies with the potential applications including 1, submarine and underwater mine detection. 2, enhanced situation awareness for naval operations. 3, precision tracking and identification of underwater objects in cluttered environments, just to name a few. This advanced optical receiver will be a critical enabler for the next generation of underwater imaging and threat detection systems, ensuring operational superiority in complex maritime environments. Alphacore's innovation is enhancing underwater optical imaging using multi-element receivers. Currently, most high-power modulated blue-green laser systems rely on a single wideband optical detector receiver system that mechanically scans the target volume. While effective, this approach is time-intensive, often requiring several minutes even with state-of-the-art systems. This delay is a critical limitation for today's dynamic applications, such as imaging in moving platforms or fast-changing underwater environments. Recently, researchers at NOCAD have developed an alternative approach to underwater optical imaging. Their method uses a laser to transport a radar signal through the water, offering a more efficient way to enhance imaging performance. Alphacore's proposal complements this approach, leveraging its expertise in advanced detector and amplifier technologies to address the limitations of current receiver systems. Alphacore's proposal includes the following. 1. Use of advanced avalanche photodiode technology, where at Alphacore we utilize the X8018 APD from XFAB, known for their high responsivity and quantum efficiency in the blue-green spectrum. Also, extensive evaluations show that the APDs can achieve significant performance gains. For example, their average optical responsivity increases by approximately 100 times at a 19-volt reverse bias, which is ideal for detecting weak signals. Number 2, integration of transimpedance amplifier circuit design technology using TIAs from Tower Semiconductor that will be used to achieve low noise, high gain, and linear performance. Their signal handling is ideal for the proposed system, as it's optimized for signals ranging from 6 photons per nanosecond to 1460 photons per nanosecond, covering scenarios like bottom reflections and surface backscatter. Number 3, multi-element optical receivers will be developed. Where a multi-element optical receiver capable of gigahertz level bandwidth will replace the single element mechanical scanning systems, and enhanced spatial resolution of this receiver will significantly improve imaging capabilities without mechanical scanning. Also, compatibility with moving platforms, where unlike concurrent systems, this approach is well suited for integration into the moving platforms, enabling real-time imaging in dynamic environments. So while transmitter side technologies have successfully produced high bandwidth optical integration signals, the receiver side innovations have lagged, namely mechanical scanning limitations for single element receivers require mechanical scanning, making them unsuitable for rapid or mobile imaging applications, and inadequate time resolutions for like automotive time of flight cameras, while effective for certain industries, lack the time resolution needed to operate in high clutter underwater environments. Therefore, a multi-element wide bandwidth optical receiver offers the potential to achieve high time resolution, spatial resolution, and compatibility with these dynamic operations. The key advantages of Alphacore's approach are high sensitivity in blue-green wavelengths, where we leverage APDs for superior responsivity that ensures optical detection in underwater scenarios, low noise, high gain systems for integration of the APDs and TIAs, where they deliver exceptional performance across wide range signal intensities, faster imaging, replacing mechanical scanning with spatially resolved dynamic detectors, dramatically reducing imaging time, and adaptability to complex environments where the system's ability to distinguish signals in uncluttered conditions is vital for underwater threat detection and mapping. The approach then represents a paradigm shift in underwater optical imaging, combining cutting-edge detector technology with innovative system architecture to overcome existing limitations and meet the demands of modern naval applications. Alphacore's wideband multi-element optical receiver offers a cutting-edge solution. Notably, Alphacore's innovation lies in its advanced wideband and multi-element optical receiver specifically designed to meet all NORCAD's warfighter underwater receiver requirements. The receiver leverages state-of-the-art CMOS technology to deliver unmatched performance for underwater and imaging and threat detection applications. Alphacore solution is a highly integrated two-chip CMOS module that includes 1. Sensitive linear mode APDs optimized for blue-green wavelengths, ensuring exceptional optical detection performance. 2. Integrated functionality where the module incorporates waveform samplers, digitizers, serializers, and IOs that eliminate the need for additional external components. And 3, Alphacore's proven technology where many of the components have already been demonstrated on silicon in the selected processes. The new circuitry specific to this program was designed and thoroughly simulated during Phase 1, ensuring a solid foundation for the further development. The image on the right shows the two-chip solution that will use 1 or 2 lines of APDs, each line being made of 5 or 100 or 600 APDs, illustrated as a long horizontal chip in the center. For optimized product yields and flexibility mix and match process choices, smaller TIA readout chips above and below the APD chip are used. Alphacore's approach uses a two-chip solution on the XFAB 180 nanometer APD and Tower 65 nanometer for the TIA RF processes. Major advantages of Alphacore's two-chip solution include 1. ITAR compliant process, which is where critical features are developed using ITAR compliant processes ensuring secure and reliable technology suitable for defense applications. 2. Smaller channel pitch, which enhances spatial resolution and performance while operating at speeds significantly faster than the 180 nanometers XFAB process. 3. Lower voltage, making the system more efficient and suitable for mobile or resource-constrained platforms. 4. Faster transistors, which are optimized for high-speed operation with demonstrated logic speeds 5 to 10 times faster than the alternative processes. 5. Lower power consumption, which improves the system's thermal efficiency and operational endurance. And 6. Proven reusability, whereby Alphacore has successfully migrated these technologies in multiple other programs and circuits allowing for reuse and fast deployment in this program. Some of the benefits of Alphacore's solution for NORCAD's underwater applications include high-speed operation, which is ideal for high bandwidth signal processing required in underwater environments, enhanced detection capabilities where the integration of APDs and advanced circuitry ensures superior sensitivity and resolution even in cluttered conditions, compact and efficient design where the two-chip solution offers a smaller form factor and reduced power requirements, making it compatible with moving platforms, scalable technology where proven components and reusability reduce development risks and timelines, and ITAR compliance, which ensures secure and compliant technology for sensitive defense applications. So overall, the innovative optical receiver represents a significant leap forward in underwater imaging technology, providing NORCAD with the tools needed to meet modern warfighter requirements. Alphacore's solution will not only address current challenges, but also sets a standard for performance, efficiency, and reliability in underwater sensor systems. Wideband multi-element optical receiver was successfully presented to the TPOC during a Phase 2 base period status meeting. The presentation focused on the innovative two-chip solution's advantages, emphasizing its thermal stability, performance, and compliance with ITAR requirements. The TPOC team approved the design based on these strategic advantages. The image on the right side is a block diagram of Alphacore's multi-mode pixel/element ROIC cell. The key advantages and benefits of the two-chip solution include: 1, thermal stability and resistance offered by the two-chip configuration, which enhances the receiver's resistance to thermal fluctuations, ensuring stable performance across diverse operating elements. 2, improved performance through the design, where the design allows for faster, more reliable operations meeting the demands of high speed, high accuracy underwater imaging and detection applications. And 3, ITAR compliance through the simplified ITAR related considerations, where the two-chip design make it suitable for suitable defense applications while maintaining strict adherence to export control laws. To optimize chip performance, the two chips will be fabricated using different technologies. The DROIC will be fabricated using Tower Semiconductor's 65 nanometer process, which ensures higher efficiency, lower power consumption, and faster operations. And the APD chip will be fabricated using XFAB's 180 nanometer process, which is chosen for its compatibility and proven performance in other APD applications. This design is flexible, allowing future adaptations to leverage other technologies, further enhancing its scalability and versatility. With regard to assembly of the module, the two chips will be wire bonded into a two-chip compact module. This configuration simplifies integration and other system components and optimizes space usage, making it suitable for compact underwater sensor systems, and provides a scalable architecture for adapting to future performance enhancements. This innovative receiver design aligns with the program's objectives by offering a number of advantages. First, enhanced imaging and detection capabilities in underwater environments, compatibility with high-speed, high-clutter environments critical for military applications, a robust, scalable platform adaptable for future advancements. The project is presently at TRL 4, which reflects the successful transition from conceptual design to initial testing phases. At the conclusion of the program, the project aims to achieve a TRL 6, which signifies a significant leap in the confidence in advancing the project through rigorous testing and development milestones. With regard to financial and progress update, the current expenditure as of the last report, Alphacore has incurred a total of $367,254.87 in labor and hour costs. This represents approximately 20% of the total program budget of $999,896, indicating that the project is advancing according to plan. The modified work plan and current progress suggest that the project is successfully adhering to the revised plan. No significant delays or cost overruns are reported, ensuring alignment with the allocated resources. So to categorize the current status, Alphacore's strategic transition to a two-chip solution underscores the adaptability and technical foresight of the team. With the current progress at TRL4 and a clear pathway to TRL6, the project demonstrates strong potential for achieving its goal while maintaining budget and timeline adherence. The wideband multi-element optical receiver developed by Alphacore surpasses NORCAD's warfighter underwater receiver specifications by providing a rapid and efficient imaging solution. This advanced optical receiver leverages spatially resolved detectors to deliver real-time imaging and analysis capabilities essential for underwater threat detection and navigation in cluttered environments. Alphacore's optical receiver module features the following benefits, including 1, wide bandwidth with multi-element design that enables the simultaneous extraction of both reflectivity and range features in objects in water, and this is critical for distinguishing desired object returns from environmental clutter. 2, high sensitivity at visible wavelengths that is optimized for blue-green wavelengths where light transmission in water is most effective. The module is designed to operate in high clutter environments with sufficient dynamic range to detect faint signals. 3, superior responsivity and quantum efficiency made possible by the linear avalanche photodiodes with tremendous responsivity and quantum efficiency in the blue-green wavelengths. Based on collaborative insights from Navy LiDAR designs, the module can handle a wide signal range from 6 photons per nanometer to 1,460 photons per nanometer for bottom reflection and surface backscatter. Number 4, optimized APD design, where Alphacore has conducted extensive research to select APDs that deliver low noise and high gain and linearity. Responsiveness increases by approximately 100 times at a 19-volt reverse bias, ensuring exceptional detection performance. 1D array architecture was strategically chosen because of its advantages over 2D arrays. So 2 key advantages over 2D arrays. The higher bandwidth of a 1D array achieves 2 times the bandwidth compared to its 2D counterpart. The improved performance is 10 times the quantity of samplers per pixel, higher sampling rates and frame rates, lower noise levels and greater reliability, reduced limitations. In other words, the 1D architecture eliminates layout area and signal routing complexities, which are common in 2D arrays. And then the limitations of 2D arrays are that while 2D arrays are suitable for some specific applications, they are constrained by design complexity and scalability challenges. Evaluating these limitations has provided valuable insights for Navy applications, ensuring a tailored solution with the highest potential performance. Therefore, in Phase 2, Alphacore's focus will be on the 1D array architecture. The Phase 2 option program will prioritize the continuation and optimization of the 1D array design, and early program progress allows for design refinements refinements, ensuring the module's architecture aligns with performance goals and application needs. Therefore, Alphacore's wideband multi-element optical receiver demonstrates a cutting-edge approach to underwater imaging, delivering unprecedented performance in reflectivity and range detection by combining advanced APD technology, superior blue-green wavelength efficiency, and the strategic adoption of a 1D array architecture. The solution addresses current challenges in underwater optical detection. This with continued development under Phase 2 option program, Alphacore is poised to deliver an advanced receiver module that meets or exceeds NOACAD's operational requirements. Alphacore's advanced optical receiver module is designed to address critical challenges in underwater LiDAR remote sensing for mine countermeasure ships mission packages, MCM, and other naval applications. The innovation offers a cutting-edge solution tailored to meet Navy's next-generation operational requirements for underwater detecting and imaging. So key next-generation applications include Navy mission systems for LiDAR integration, such as PMS 420, LCS mission modules, and where integration goes into AN/AQS-20C mine hunting sonar applications, PS-495 mine warfare systems for enhancing the airborne laser mine detection system, ALMDS, and coastal battlefield reconnaissance and analysis, brackets COBRA systems. Office of Naval Research, ONR, Ocean Battle Space Sensing, and support for Division 322 Ocean, Atmospheric, and Space Sciences for focusing on littoral geosciences and optics under ONR 332LO. Operational Test and Evaluation Force, OPTEVFOR, Persistent Maritime Systems, alignment with programs for rotary wing unmanned aircraft systems and organic mine countermeasures, OMCM. Additionally, Alphacore plans to collaborate with its system of OEM contacts to integrate its optical receiver module into existing and upcoming LiDAR systems. This includes working with Arete for ALMDS and COBRA systems, Raytheon or RTX for AN/AQS-20C sonar systems, Northrop Grumman for ALMDS and OMCM systems, L3 Harris for systems supporting C5ISR-T applications. These applications will help Alphacore meet program-specific needs for LiDAR systems requiring advanced ASIC capabilities. One of Alphacore's strategies will be focused on replacing streak tube imaging LiDAR, or STIL. Alphacore's precision optical receiver is poised to replace the Navy's currently deployed STIL systems by offering improved optical detection precision, enhanced bandwidth with sensitivity for underwater imaging, and high definition and reliable detection under challenging marine conditions. There are also opportunities for expanding applications into MCM mission packages. Alphacore's module is ideally suited for small platform underwater detection systems, where applications include anti-torpedo systems, autonomous underwater vehicles, AUVs, and seafloor sensors designed for portable underwater satellite monitoring. The DoD and DHS remote sensing, supporting ground forces such as Marines, Navy SEALs, and homeland security operations for similar underwater and remote sensing applications. Therefore, it's clear Alphacore's optical receiver module offers a transformational approach to Navy LiDAR applications, replacing legacy systems like STIL with precision, performance, and versatility. By integrating with key Navy programs and collaborating with system OEMs, Alphacore is set to provide next-generation capabilities for underwater detection, imaging, and surveillance across various naval and defense missions. The module's scalability and applicability to other DoD, DHS use cases further demonstrate its potential for widespread adoption in remote sensing opportunities and operations. Alphacore aims to upgrade the current Navy street tube imaging LiDAR systems by introducing higher resolution LiDAR receivers. This innovation represents a significant leap in sensor technology, addressing the limitations of deployed STIL systems and offering enhanced capabilities for underwater and airborne applications. The higher resolution optical receivers are tailored to meet the demands of modern naval missions. In addition to replacing STIL systems, Alphacore's optical receiver technology can be adapted for hybrid LiDAR radar systems that the Navy has implemented over the years. This dual-use technology provides greater versatility in detecting, identifying, and tracking underwater and airborne targets, making it an ideal fit for the Navy's diverse operational needs. Transitioning these systems into Navy's fleet is a strategic pathway Alphacore will actively pursue. In addition to Navy applications, Alphacore's optical receiver technology has broad applicability across the DoD and DHS, where key applications could include for ground forces like Marines and Navy SEALs, remote sensing technologies for tactical missions, including reconnaissance, target acquisition, and environmental mapping. And for Homeland Security, they have needs for detection systems for border security, underwater monitoring, and coastal surveillance. Alphacore will capitalize on its established relationships with these key contacts in the Navy, at the DoD and DHS, as well as with defense contractors and industry partners. These partnerships will pursue commercial opportunities, refine product specifications, and help secure funding or licensing agreements. Alphacore's development and commercialization strategy during Phase 2 will include items like the following. 1, engagement with industry partners. So during Phase 2, Alphacore will collaborate with its network of contacts to define desirable end product specifications, seek funding support for development efforts, and explore near-term intellectual property licensing opportunities and non-recurring engineering revenue streams. 2, prototype development. By the conclusion of Phase 2, Alphacore will develop an initial prototype of the optical receiver for rigorous testing and evaluation. This prototype will showcase the technology's capabilities and suitability for Navy applications and broader commercial use. 3, beta testing and partner engagement. During this time, Alphacore will engage beta customers and commercialization partners to refine the product and prepare it for market entry. Alphacore will solicit feedback from target OEMs and defense contractors, etc. Alphacore has already identified several target market and end users for its optical receiver technology. These markets and applications will be pursued during Phase 2. For instance, of interest are number 1, U.S. Navy applications that include airborne mine countermeasures, replacing the still receiver in airborne MCM systems to improve detection and imaging capabilities, anti-submarine warfare, ASW, advanced optical receivers for ASU systems, both airborne and otherwise, to enhance underwater detection and tracking capabilities, anti-surface warfare, ASUW, leveraging high-resolution optical receivers for surface-level target detection and identification. 2, broader market segments, defense and aerospace industries requiring next-generation LiDAR technology, land and marine autonomous vehicles needing precision environmental sensing, airborne systems with high-resolution imaging and detection requirements. So Alphacore's direct marketing strategy will adopt a focused marketing approach to promote its optical receiver technology. The plan is to engage with LiDAR manufacturers and prime defense contractors already supplying to the DoD and highlight the technology's superiority in terms of resolution, efficiency, versatility across a variety of military and commercial applications. So in conclusion, by aligning with naval programs, engaging key stakeholders, and delivering a high-performing prototype, Alphacore aims to secure its place as a leader in advanced LiDAR receiver technology. This approach ensures smooth transition from development to deployment, benefiting both military and commercial markets. As we conclude this presentation, I'd like to reiterate Alphacore's commitment to supporting the Navy and other stakeholders within innovative optical receiver technology. Our goal is to provide a solution that enhances operational capabilities and delivers measurable benefits in real-world scenarios. We invite you to contact us to explore how this technology can address your specific needs, whether through partnerships, licensing, or direct integration into your systems. Alphacore is ready to collaborate and deliver results. Thank you for your time today. We look forward to discussing how Alphacore can support your mission and contribute to your success. Please don't hesitate to reach out to Andrew Levy or Phil Davies for more information.